Alright, I'm going to do a whole series of these where I'm going to put up two structures and I'm going to ask you what the relationship is between those. I'm not asking about, romantic gossip. I want to know their isomeric relationship. So the choices are in the upper right. They'll stay the same in all these videos. And the choices are, the two structures could be exactly the same. That is, they're not isomers of one another, they're the same structure. And that could be turned around or flipped or whatever. The other is that they're not isomers at all. They don't have the same molecular formula. Okay? Finally, they could be constitutional isomers. They could be conformational isomers, two different conformations that can freely switch back and forth. They could be diastereomers. They could be enantiomers, that is, stereoisomers of some sort. They could also be mesostructures that are the same. All right. So for the first one, I'm going to hide here. I'm going to hide what I'm doing. Okay, so take a look at these, hit pause. This should show up pretty well on the screen. I'm going to come around here and make sure they actually do. Yes, they do. So hit pause and figure out which of the isomeric choices applies. Okay, you're back. First of all, the first question to ask, are the two molecules superimposable? That means, can you lay one over the other and they'd be the same? By picking it up, moving it around, handling it like an object. And you can't. The first point of difference is what you want to look at. So in the molecule on the left, you've got two methyl groups on the same carbon. There's no carbon in the cyclohexane ring on the right that has two methyls on the same carbon. So they're not superimposable. Okay, so they're not the same. Are they isomers at all? So you want to calculate up molecular formula. 6 carbons, 7, 8, 9, and an OH. C9O. How many hydrogens are there? You can count them up, or you can just say 1 unsaturation. And that means that you could calculate out how many hydrogens there are. Over here you've got 1, 2, 3, 6 in the ring. So this is C9O. There's a ring, so 1 unsaturation. So there must be the same number of hydrogens. So they have the same molecular formula. Let's go ahead and figure out what that is. So C9, 2 times 9 is 18 plus 2. So C9, a saturated C9 hydrocarbon has 20 hydrogens. There's 1 unsaturation, so take 2 away. So this would be C9H18. And if we count this up, 3, 6, 9 for the methyls, 2, 4, 6 for the CH2, so 9 and 6 is 15, 16, 17, 18. Works out. All right, so they're isomers. The next thing then is to figure out if they're connected the same. I actually already told you the answer to this. Molecule on the left has 2 methyls on this carbon. There's no carbon in the molecule on the right that has 2 methyls on it. Don't go any further than that. You don't have to go all the way to the end of an analysis. If they're not connected the same, they can't be a stereoisomer. They can't be a conformational isomer. We figured out they're isomers. We figured out they're not connected the same. So they have to be constitutional isomers. Alrighty.